but it's not the only one. If one applies various forms of energy to the O2 molecule, it will break down to its ionic state and reform into another configuration, one where 3, not 2 atoms of oxygen stick together to form a new molecule. And this new molecule is called O3, or ozone. Remember, O3, ozone. Now, the energy required to perform this little trick can come from quite a few different sources. An electrical discharge through the air will do it, and is probably one of the most common forms that you will recognize. Unlike oxygen O2, which is odorless, ozone has a distinct pungent smell. That's what you smell after a thunderstorm. Remember, you walk out after lightning strikes somewhere, or there's been a lot of lightning in the atmosphere, and you can smell that peculiar smell that smells kind of nice, actually. That's ozone. Now, if you've never smelled that, go around your house somewhere and pick up your kid's electric train engine or radio-controlled car after it's been operating for a while, and you'll smell this odor. That's because the electrical discharge where the bushes run on the motor turns a certain amount of oxygen, O2, into ozone, O3. Electrical storms, or at least the subsequent bolts of lightning, ionize a great deal of the surrounding air and create a certain amount of ozone. But folks, listen to this now. It's going to make you feel a little bit silly when you find out what the biggest source of energy for the conversion of oxygen O2 into ozone O3 is. It's the sun, or the energy from the sun, in the form of ultraviolet light. Now, if you're really intelligent and you're really smart, you already know what I said, don't you? Check this out. They're saying that the ozone layer is being depleted, and it's being depleted. Ultraviolet light is coming through the atmosphere, striking our skin and causing us to die. You understand what I'm saying? But it can't be happening, folks, because the biggest source of ozone in the atmosphere is from ultraviolet light. Ozone doesn't protect us from ultraviolet light. Ozone is formed from ultraviolet light. Do you understand what I'm saying? Ultraviolet light cannot come through the atmosphere without striking molecules of oxygen, and when it does, it forms ozone, and the ultraviolet light is depleted by this chemical reaction. Do you understand? Ozone is not protecting us from ultraviolet light. No, oxygen protects us from ultraviolet light by depleting the ultraviolet light when the ultraviolet light strikes the molecule of oxygen and turns it into ozone. What happens is a cycle something like this. You and I breathe in oxygen, called O2, and breathe out CO2, carbon dioxide. Plants, on the other hand, breathe in carbon dioxide and expel oxygen. The cycle is more or less endless. And as long as there's oxygen in the atmosphere, we're okay. And you know what? I measured the percentage of oxygen in the atmosphere. It's exactly the same as there was 80 years ago. 80 years ago. How about that? I also measured CO2. It's the same also. Now, if you measure these near cities, then you get radical readings. But if you go way out in the country and measure the atmosphere, there's no difference than 80 years ago. And if you don't believe me, you can do it yourself. You can buy oxygen and CO2 analyzers from Beckman Instruments, and you can go out and measure it yourself. CO2 analyzers, oxygen analyzers. How do I know this? How do you think we measured the mixture of gases that we were making up for divers to dive with so that they would have the right mixture and it wouldn't kill them? You see, folks, you've really been fooled. Here's how it works. We have oxygen throughout the atmosphere. From the other direction, light from the sun streams in. A certain amount of this light is absorbed or deflected by various elements. Atoms, molecules, and particles of other matter, dust in the air, whatever. The bulk of this light from the sun, however, continues its downward journey toward the planet's surface until it encounters the oxygen molecules. At the point where the sunlight reaches a sufficient concentration of oxygen molecules, a reaction takes place. A certain portion of the light from the sun That portion known as the ultraviolet section strikes the O2 molecules and imparts its energy to the oxygen molecule it has struck. This has two effects. First, it greatly reduces the amount of ultraviolet light which would otherwise reach the Earth's surface, because the ray, or unit, or beam of light, loses energy and becomes light in the lower spectrums, the ones we call colors. This is one of the causes of that spectacular light show called the Southern or Northern Lights, Aurora Borealis. Second, it converts the oxygen molecules, O2, into ozone molecules. Wake up. There's a portion of our atmosphere from 10 to 50 kilometers up which does not, however, get this name because it contains some magical, mysterious layer of matter known as ozone, which exists and has existed from the beginning of time to protect us from ultraviolet light, and which is now under dire threat from various man-made products. No. That is a crock of crap. It's a hoax. It's a lie. I like lie better because that's what it really is. It's a lie. It's called this name because this is the region where oxygen molecules are struck by incoming ultraviolet light and convert to O3, or ozone molecules, and it therefore has a slightly higher proportion of ozone molecules to oxygen molecules. Why only a slightly higher portion? Because remember, the atmosphere is constantly mixing. It doesn't stay there very long. And remember that ozone is a free radical. As soon as it strikes something that will oxidize, it reverts back to a molecule of oxygen, and the free radical forms with whatever was oxidized. Do you understand? There will continue to be an ozonosphere, and that's what it should be called. It's not an ozone layer, it's an ozonosphere, or as it is incorrectly termed, as ozone layer. There will always be this meeting of ultraviolet light and oxygen in the atmosphere for as long as the planet's surface continues to manufacture oxygen to rise, and for as long as the sun continues to emit light to encounter that oxygen. You understand, we're in no danger from burning up from ultraviolet rays as long as oxygen exists in the atmosphere. It's not ozone that stops the ultraviolet light and protects us from this harmful light ray, this harmful energy from the sun. Ozone is a creation of the oxygen's protection of the earth from this harmful sun's energy. Oxygen is what does it, and oxygen is converted to ozone, which then lives only for a very short period of time because it's a free radical. How about that? That gets you a little angry? Don't shoot the messenger. Don't shoot the messenger. I'm just straightening you out here. You need to be straightened out. You see, this is no different than the meeting of the water and the land. And just as there will always be surf for as long as there are places where water meets land, there will always be ozone in places where ultraviolet light meets oxygen. The misnamed ozone layer will continue to simply be the end result of where two opposing forces and systems meet until such time as one or the other of those forces or systems just plain ceases to exist. Just as there will always be surf for as long as there is land and water, there will be an ozonosphere as long as there is oxygen and sunlight. Isn't that interesting? If either one of these packs up, we will have long since suffocated or frozen to death or something else, long before we develop skin cancer. As I said, this is stuff you can check out for yourself with the simplest of reference books. And if you hold up the statistics that say there's more people getting skin cancer now than there was 25 years ago, that's because there's more people on the beaches and out in the sun than there was 25 years ago. And if you don't believe me, check the statistics. It's true. And per capita, there's no more instances of skin cancer caused by the sun than there was per capita 25 years ago, or even 40 years ago, except that the farther back you go, the more common it was to protect yourself from the sun and stay